Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, ladies and gentlemen. I am Garindo Prayitno, the author of this article. The article title is Recent Progress of Used Deposition Modeling on FDM 3D Printing. Covers constructions, parameters, and processings. The other author is Fitrian Imaduddin as corresponding author, Ubaidillah and Zainal Arifin. And this article was presented on the 6th in the International Conference on Industrial Mechanical, Electrical and Chemical Engineering 2020. So let's get started. First, about introduction. 3D printing technology has a high potential to reduce the time and cost of making a product. The mostly widely used 3D printing method is FDM. Quality of the printing results, especially the mechanical properties, is mainly influenced by the process parameters setting in FDM. There have been many studies related to this, therefore it is necessary to summarize and look for challenge and potential improvement. So this paper aims to summarize the progress of development in FDM, which includes setting printing parameters, post-processing, and also present the summaries of future challenges and potential improvements. First, about printing parameters. This is about description. Printing parameters, and this is illustration and FDM 3D printing machine. Printing parameters are things that are set to determine the process of printing. Setting of each printing parameter has various effects on the printing result. Setting each printing parameter can give advantage in one aspect, but on the other hand, it can also cause disadvantages in other aspects. Therefore, many studies have been conducted to find out how to set the best printing parameters so that it gets the most optimal result. Okay, we entered effect of the parameters in recent studies. The first parameters is layer thickness. This is layer thickness. ICIMECE et al. In 2019 and Wang et al. In 2020 have studied the effect of layer thickness using PLA. The results is the first, gaps that form in printed objects increase when the layer thickness also increases. And then second, some small layer thickness allows the strength of bonding between layers to be stronger. However, when using a small layer thickness to get optimal result requires longer processing time. Therefore, we need supporting parameters so that optimal result can be obtained with relatively short time. Then print speed. The print speed is closely related to the extrusion speed or mass flow rate. Therefore, two parameters must be adjusted in order to get optimal result. The result of analysis Hao et al. In 2018 using PLA in his study showed that the effect of print speed was not significant, so a high print speed can be used to minimize processing time. Yang et al. Have researched different materials, namely PEK, about the effect of extrusion speed and printing speed on the dimensional stability of the extruded material. The same results are shown, and the optimization of this parameter is linear with the layer thickness parameter because the solution of this parameter can minimize the problem of processing time at the layer thickness parameter. And then the third, about extrusion temperature. Extrusion temperature significantly influences the flowing behavior and compaction process. This will also affect raster bonding, surface quality, and layer bonding, thus affecting the tensile strength. Et al. In 2019, research shows that tensile strength length to follow the level of crystallinity. Temperature extrusion settings are very dependent on the types of material used. Therefore, further research on variations in the materials used is required. And then raster angle. Lorenzo et al. Have studied the effect of the raster angle seen from the properties of the fracture with polypropylene material. This is the illustration about raster angle. The direction of the load on the application of the printed component is known. Then it is recommended to use the orientation of 0 degree because the representation is one of the best fractal properties. If the direction of loading in the component application is unknown, it is recommended to use the orientation combination. Other studies using ABS material, the raster angle has no effect on increasing tensile strength but has an effect on increasing the Charpy impact strength. And then nozzle diameter. The use of the nozzle diameter depends on two main factors, namely temperature and volume feed rate. Before and Akondi have researched the effect of parameters on FDM, one of which is the diameter result. Diameter nozzle, the results show that the smallest diameter variation of the nozzle produce the most optimal tensile strength. This diameter nozzle parameter will have more effect if synchronized with other parameters such as layer thickness, raster angle, and nozzle temperature. Then we enter to the next part about post-processing. The first post-processing is annealing. It is the most commonly used post-processing to increase the crystallinity, which then causes increasing the mechanical properties of the semi-crystalline polymer. The result of School et al. In 2020 show that annealing improves the mechanical properties of printed object at slower speed. It also increases the addition of each layer under certain conditions. On the other hand, this annealing process cannot reduce the porosity of the printed object. Then, second, about machining. Post-processing machining is usually focused in getting good surface quality. This method does not affect the internal structure or mechanical properties such as post-processing with chemical treatment. And then laser polishing. This is illustration about laser polishing. The use of laser polishing in post-processing can reduce roughness a lot and even reach the value of 0.32 micrometer. Laser polishing can also reduce porosity, increase tensile strength, increase dynamic mechanical properties, improve interfacial adhesion, and can even improve existing fracture on printed parts. Several optimizations can be done at once by using the method, which creates a particular advantage of this method. And then chemical vapor smoothing, based on Beniak et al. Research on in 2018, when exposed the acetone vapor for 5 minutes, the compressive strength increased by more than 21%. But if more than 5 minutes, the roughness value reduced and the strength reduced too. CVS also reduced the dimension slightly of the part due to reflow material and increased value to its hardness. And then we enter to the last part about future challenge and potential improvement. There are not enough data to explain the relationship between print quality and mechanical properties for the various types of materials used in FDM. And then the next challenge is there are not enough data to explain the relationship between print quality and mechanical properties for the various types of material used in FDM. There are not absolute rules and guidelines that can be used to assist users in optimizing the printing process to get the best printing result. Most studies also only show the result of the analysis of tensile and flexural properties, while other analyses such as hardness, production time, grip, vibration were rarely studied. In addition, process parameter optimization is mostly done for the mechanical properties of printing results. Meanwhile, the optimization of process parameter for thermal, mechanical, chemical, and dynamic mechanical properties is still rarely found. Studies that conduct optimization for several variables simultaneously are rarely found. Therefore, further studies on the analysis of overall mechanical performance and optimizing multiple output variables simultaneously are required to get more evident analysis result. Lastly, economic analysis is also required to determine profitable or not profitable when using post-processing on a product. Post-processing generally gives an increase in surface quality from printing result. The surface quality in result of printing with FDM is relatively pure. The surface quality of the printing result has a potential to be improved so that it no longer requires additional post processing. The conclusion is the parameter processing and post processing in FDM 3D printing have a significant influence on the final result of the printing. The effect of parameter processing and post processing on this recent study has been explained in this article. The result of a review conducted in this article show that in general process parameters have an effect on mechanical properties, surface quality, and build time. Process parameter can influence and be a solution for each other. The combination of several synchronized parameter process such as layer thickness and print speed can produce more optimal printed parts and shorter printing times. In addition, if FDM is integrated with processing, it will also get better result, especially on its surface quality. Future research with an overall analysis of mechanical properties and economic analysis is needed for more evident results. That's all. Thank you for your attention. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.